Hi guys, good morning. So our lesson today is going to be on factoring, and we're going to start out with factoring basic trinomials. So hopefully you remember a couple weeks ago, last time we were in class, we were talking about the different types of polynomials. So we talked about monomials and binomials and trinomials, and we did adding and subtracting with polynomials, and then we worked on the multiplying polynomials and the foiling method to do that when we multiplied two of them together. So that was kind of where we left off before we went to our original remote learning plan. So now we're getting back into chapter 8, and we're going to be doing some factoring of trinomials. So we're kind of doing the opposite of what we did when we did foiling. So if we take a look at the notes here, the section 8.5 notes, our goal today is going to be to factor trinomials that are in just the basic simple form of x squared plus bx plus c. So there's basically 4 different combinations of signs that you can end up with. So as we're doing these, we're going to go through the different combinations just so you can kind of see how the signs work out. So the first example that we're going to do is when both the b and the c are positive. So for all the problems we're going to do today, the a value, or the number in front of the x squared, is always going to be 1. So we don't have to worry about that. So the b is the number in the middle in front of the x, the coefficient for the x, and the c is that constant that's either adding or subtracting to the end. So let's take a look at the first type of factoring problem. So basically what we're trying to do here is we're trying to figure out what was in those 2 parentheses that we multiplied or FOILed together to get this trinomial here. So if you remember when we did FOILing, just as a little refresher, right, we had to multiply 2 things together. So for example, let me just do a little review for FOILing, right? If I had x plus 3 times x minus 7. Remember, you would multiply the x times the x, and you would get x squared. Then you would distribute that x to the negative 7. That would be negative 7x. Then 3 times x would be positive 3x. And then 3 times negative 7, negative 21. And if you have any like terms, which we do have these 2 x's in the middle here, you would combine them. So that would give you x squared minus 4x minus 21, which is a quadratic trinomial. So now we're going to be doing the opposite of that. We're going to be looking at this quadratic trinomial here, and we're trying to figure out, well, what would be in those 2 parentheses that was multiplied together to get this quadratic trinomial. So the first thing we want to look at is that first term, and you want to split that up. And the only way to get an x squared would be to multiply an x times another x. And there's only one option for that. So if you remember when you do like your foiling, right, you multiply those first 2 terms, and that's where that x squared comes from. So the first step we do for the simple factoring is we just split up that x squared into an x and an x. Then the 2 numbers that are the second number in each of those binomials, they have to multiply together to get this c term. So since I have a positive 24, we know that they have to be factors of 24, which means they're 2 numbers that multiply together to get 24. So let's think of all of those possible options. So of course, there's always 1 times 24, right? 2 times 12, 3 times 8, and 4 times 6. Those are all the different combinations of numbers or factors that multiply together to get 24. Now, we also notice that there's a positive 24 here. So that means that the 2 numbers that multiply together would have to have the same sign, because the only way to get a positive is to multiply 2 positives or 2 negatives. So the sum of the factors. Now, whenever this is a positive, you know that the 2 numbers that you're going to be using have to add up to get the middle number, okay? So 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11, and 4 plus 6 is 10. Now we want to get a 10 because that's what's in the middle. So we're looking for the combination of factors that multiply to 24 but add up to 10. So which of those from the list would do that? Well, you probably figured out by now that it was 4 and 6. So when we go to do our two binomials, we know we had x and x. We know we're going to have 6 and 4 or 4 and 6. It doesn't matter which order you put them in. You could put the 4 first or the 6. It doesn't matter. Now, the key is the signs. As we said, we know that they have to have the same sign, but because that middle number is positive, a positive 4 and a positive 6 would add up to give us that positive 10. So we know that these are both going to have to be positives. So let's try a few examples. Now, I would encourage you guys, if you feel like you're confident enough to try the problems, pause the video, try them, turn it back on, and see if you got the answers. So doing these examples, first thing you want to probably start out doing is just setting up those two binomial parentheses before you do anything else. And because our first term is just x squared right away, I'm going to go ahead and put x and x in those parentheses. Next thing you're going to do is you're going to look at that number at the end. Now we have a positive 16. So if you're good at thinking of these in your head, that's great. If you're not, make a little list on the side. So I always start out with 1 times the number, right? Then 16 divided by 2 is 8. 16 divided by 3 doesn't work. Then 16 divided by 4 is 4. And once you get two numbers that are the same or like very close together, then you know you're done with your factors. So now with 16, which of these pairs or which of these sets of factors will add up to get us a positive 10? So that would have to be 2 and 8. So we're going to put those in. I usually like to do the bigger number first, so I always put 8 and then the 2. And because they're going to add up to give us a positive 10, they're both going to be positive because positive 8 times or adding positive 2 gives you that positive 10 in the middle, but if you multiply them, you get the positive 16. So now how would we check our work for this? So if we want to check our work, and I'm going to do this for a couple just to review, you do that foiling to check. Okay, so if we were going to check this one, we would do x times x, which is x squared, then x times 2, positive 2x, 8 times x, positive 8x, and then 8 times 2 is positive 16. And then, of course, those middle two terms are like terms, so you would add those up. And notice that you get back to that original problem, and that's what we're trying to do there. So I'm not going to check it every single time, but just to kind of show you how that foiling process works. So let's take a look at number 2. So number 2, again, first thing I would do for any of these basic trinomials where they're starting with just that x squared, right away set up your two parentheses with the x in the beginning of each one. Then the next thing you want to do is look at this last number here, figure out what are the factors. Well, 5 is nice and easy. There's only one pair of factors to get 5, which is 1 and 5. And we know that there's a plus sign here, so the two factors are going to have to add up to get 6. And of course, 5 and 1 does add up to get 6. So like I said, when this is a positive, both signs have to be the same. And if this is a positive in the middle, then they're both going to be positive because they have to add up to get the middle number and multiply to get this number at the end. Okay, let's try to look at the next two. Okay, so for number 3, first thing we're going to do is set up our two parentheses with x and x. Now we need those factors of 18. So 1 times 18, 2 times 9, or 3 times 6. Those are all of our factors of 18. Now we need the pair of factors that's going to add up to give us a positive 9. So what would that be? Well, 3 and 6 will add up to 9. And since it's a positive 9, we know that's going to be positive 6 and positive 3. And again, if you want to check that answer, you can just FOIL it to check it. And let's do one more with the plus-plus combination. So x and x, we need our factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. So we need the factors of 36 that add up to get us the 15 in the middle. And it's a positive 15, so they're both going to be positive. So which combination will add up to 15? 3 and 12, and they're both positive, so positive 12 and positive 3. And again, you could write that in the reverse order if you want to write x plus 3 first and x plus 12 second. Still works, it's just personal choice. All right, so let's move on to the next page. We're essentially going to do the same thing here, but you'll notice that this time the middle number has a negative sign on it. So when we go to do this problem, that's a little bit different. So now we still have this plus sign here, which tells us the signs are going to still be the same because the two numbers that multiply together to get that 9 when we FOIL still have to equal positive. So they have to either be two negatives or two positives like we talked about on the last page. But because the middle one is negative, they're both going to be negative. So some people right away would like to set up their parentheses x minus, x minus. I usually like to put my signs in at the end just because I kind of mentally check it to make sure it's going to work out as I do it. But if you realize that it's a plus in the middle and a negative in the middle and a plus at the end, then you can just do minus, minus. So same concept though. What are the factors of the 9? Well, it's either 1 and 9 or 3 and 3. Again, this is a plus sign here, so they're still going to add up to that middle number. So 1 plus 9 equals 10, and 3 plus 3 equals 6. Well, I need the middle number to be a 10, so obviously I'm going to pick 1 and 9. But because it's a negative 10, I need a negative 1 plus a negative 9 to give me that negative 10. So then I know that this is going to be x minus 9 and x minus 1. And then, of course, if I want to check that, you're going to do your FOIL to check. So x times x is x squared. X times negative 1 is negative x. Negative 9 times x is negative 9x. And negative 9 times negative 1 is positive 9. So that would combine the like terms in the middle, gives me that negative 10x in the middle that we wanted. And we have the same exact quadratic trinomial that we started with in the beginning. So then we know that we factored it correctly. So let's try a few examples with the negative positive combination. So again, first thing that I recommend you guys do, as soon as you see it's a quadratic trinomial and there's nothing in front of that x squared other than technically a 1, right away, 2 parentheses, x and x. Now, like I said before, if you want to and you see that this is a plus here, you know the signs are the same. This tells you they're both negative. So if you want to go ahead and put those negatives in the beginning, you're more than welcome to do that. But now I'm going to do my factors of 12. Okay, so 1 times 12, 12 divided by 2 is 6, 12 divided by 3 is 4. So which of these combinations is going to add up to give me a 7? That's right, 3 and 4. And again, because it's a negative 7, that's why it would be a negative 4 and a negative 3, because that's how you would get the negative 7 in the middle when you add them or combine those like terms. But when you multiply the two negatives, you'll still get that positive 12 at the end. All right, so let's try number 6. Okay, again, 2 parentheses, x and x, right? Again, if you want to go ahead and put the signs in from the beginning, since you know it's a plus, the signs are the same, they're both going to be negative. So this C value this time is a 7. The only factors I have for 7 are 1 times 7. And of course, 1 and 7 do add up to 8, so that looks good. Now when I put my numbers in, they're both going to be minus signs because negative 7 plus negative 1 would equal the negative 8 in the middle. But when I multiply the negative times the negative, I get the positive 7. All right, next 2 examples of this type. So I set up my parentheses, we got x, we got x. If I look at my signs, I know they're both going to be negatives. So now I just have to find my factors of 24 that add up to 11. So 1 in 24, 24 divided by 2 is 12, 24 divided by 3 is 8, and 24 divided by 4 is 6. And those are all of our factors of 24. So now which of those factors add up to 11? Well, 1 and 24 doesn't, 2 and 12 doesn't, 3 and 8 adds up to 11. So I know my numbers are 3 and 8, and of course they're both negative because a negative 8 and a negative 3 would add up to that negative 11. And then finally, the last problem, we have x and x, and again, they're both going to be minuses because this plus here means the signs are the same, and this middle number tells me they're both negative. So I need factors of 36. So 1 and 36. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. And 6 and 6. So which of these pairs of factors will add up to get me 13? So that would be 9 and 4. And of course, in order to get the negative 13, both the 9 and the 4 would have to be negative. So they could add up to negative 13, but still multiply to get a positive 36. So hopefully you guys are starting to see how the signs kind of work out with these problems. Because now on our next two types that we're going to do, you'll notice that the last number is negative this time. So this makes it a little bit trickier because the signs are going to be different. So the way I always kind of remember this is when you have subtraction, that means difference, right? We've learned that way back in the beginning of the year. So if you have a minus sign there, difference, different, that's kind of what I remember. So you're going to have one of each, right? But the bigger number of the two, the bigger number will have the sign from the middle. So what does that mean? So that means of my two numbers, the two factors that I pick, the bigger of the two is going to get the plus, and then the smaller one will get the minus. So whatever sign is here in front of my middle term, that's what's going to be on your bigger number of the two numbers. So first, let's figure out our factors of 7. Well, we only have 1 and 7, right? So we need them to subtract to get a 6. So it would have to be 7 minus 1 to get us that positive 6, right? Now, if you think about it, as I said to you, you figure out your two numbers, right? The bigger one's going to get the plus. Then the smaller one will get the opposite sign, which will be negative. And that makes sense because positive 7 and negative 1 will add up or combine to get me the positive 6. But when you multiply the two, if you're foiling, when you multiply, that's when the negative times the positive will equal that negative. So we have to FOIL here to check it. X times x is x squared. Then x times negative 1 is negative 1x. 7 times x, positive 7x. And 7 times negative 1 will be negative 7. And then when you combine those two in the middle, that would give you that positive 6 in the middle. Okay, so the moral to the story is for these next 4 problems, all of them have a minus sign, right? So that means on all 4 of these sets, you're going to have one of each. You're going to have a positive and a negative. Now, whatever sign is on that middle number, all of these have a positive on that middle number. So on all 4 of these, the bigger number of the two factors you pick is going to get the plus sign, and the smaller number is going to get the minus sign. And that's why I like to always put the bigger number first, because it kind of helps me keep it a little bit more organized. So sometimes some people like to go ahead and just kind of fill in the portion that they're already kind of going to know, right? So now we're going to do our factors of this last number, just like we did in the last few pages. So the factors of 63, of course, 1 and 63, it's not divisible by 2, but is divisible by 3. So you get 3 and 21. 4 doesn't go in, 5 doesn't go in, 6 does not go in, and then you don't have any more factors until 7 and 9. Now, which of these pairs subtract to get a 2? That's how you figure out the numbers. So which of these pairs could you subtract to get a 2? 7 and 9. Now remember what I said, the bigger of these two numbers is going to get the plus, the smaller will get the minus. So it's going to be positive 9 and negative 7. And then if you want to check it using your foiling, then you can go ahead and check it. So like if we want to do that for this one, let's say, we get x times x is x squared minus 7x plus 9x minus 63, and then you can make sure that those middle numbers add up to what you had on that original problem, just like that. All right, so let's try number 10. So this time we need our factors of 28. So 1 and 28. 28 divided by 2 is 14. 3 does not go in evenly, and then 4 goes in 7 times. So which of these pairs of factors would subtract to give me a 3? So look at those numbers closely. Which pair could you subtract to get a 3? Well, 7 minus 4 would equal 3. So we know we're going to use 7 and 4. Now, if you do the signs the way I did it already, and the bigger number always gets this plus, I know that it's x plus 7 and then x minus 4. You can also kind of combine those in your head to make sure positive 7 minus 4 does equal that positive 3 that we have there in the middle. All right, so let's do the last two on this page. So the factors of 20, so I have 1 and 20, 2 and 10, 4 and 5. And of course, this time I have a subtraction sign, so I need to know which of those pairs is going to subtract to give me an 8. So 20 and 1 would subtract to give me a 19. 5 and 4 would subtract to give me 1, but 10 minus 2 gives me an 8. So I know I have a 10 and a 2. Now the plus sign is going to go on the bigger number, since there's a plus here. And then the other number, the 2, is going to get the other sign, which is the negative. And then the last problem, factors of 34. So 1 and 34, 2 and 17, and I think that's it. So now which of these pairs of factors will subtract to get me 15? Well, 17 minus 2 equals 15, so I know that's my pair of numbers. The bigger number is going to get the plus sign, so that would be the 17, and then the smaller number will get the minus sign. And then we've got one more combination to do. That would be this page here, example 4. Okay, so notice this time. Okay, so on example 4, this time you'll notice that there's a minus sign again here, which means the signs are still different. But this time, the bigger number gets the negative because there's a negative on your middle term. So just like the last set, the signs will be opposite, 1 plus, 1 minus. Last time, the bigger number was always positive because we had a plus on the middle term. But this time, since our middle term is negative, the bigger number will always get the negative. So if we were going to do this one, I know that it's x and x right away. And because the signs are different, I'm going to have a minus and a plus. Now, factors of 11, the only factors of 11 are 1 times 11. And because I know this is a negative here, the bigger of those two numbers is going to get the negative, which would be 11, which would mean the 1 will get the positive. And that makes sense because negative 11 plus 1 would equal that negative 10 that I have in the middle. And again, as normal, you would check by doing FOIL. So x times x is x squared. X times 1 is 1x. Negative 11 times x. And negative 11 times 1 is negative 11. And then those two like terms in the middle would combine to get me that negative 10x that I wanted. And now we see that it's correct because it matched up to the original problem. So let's do a couple of those types of examples where we have both signs negative. So again, if you want to, you can certainly just before you even think about it too much, just set up your two parentheses for your binomials, put your x's in there. And since both signs are negative, we know they're different and the bigger number gets the negative. But you can figure the numbers out after. So if you want to go ahead and put the signs in the beginning, you can. So now let's look at our factors of 63. So 1 times 63, 3 times 21, and 7 times 9. So which of these pairs, now this is a minus sign, so they have to subtract to get that middle number, which is 2. So 7 and 9 would subtract to get 2, right? 9 minus 7. So we know those are the numbers that we're going to use. So now we got to put them in the parentheses. But the bigger of those two numbers is going to get the negative. So the 9 is bigger than 7. So the 9 is going to get the negative, and the 7 will get the positive. So let's try number 14. This time we have a 36 for our third term here. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And this time, since there's a minus, they need to subtract to get us this 5 that's in the middle. So which of these pairs would subtract to give us 5? So if you look through the list, 36 minus 1, no. 18 minus 2, no. 12 minus 3, no. 9 minus 4, yep, that's 5. So we know the two numbers that are going to go in the parentheses are 9 and 4. But the bigger of those two numbers is going to have to get the minus sign. So the 9 goes with the minus, and then the 4 would go with the plus. All right, and 2 more of those. Okay, again, I'm going to do x minus and x plus because I see that I have an x squared, and this negative here tells me my signs are different. So now let's figure out what the numbers are. So 22, what are the factors of 22? 1 and 22 or 2 and 11. Which of those pairs subtracts to give me the 9 that's in the middle? 11 minus 2 equals 9, right? So those are the numbers that we need to put in. The bigger of those numbers, though, is going to get the negative in this problem. So the negative is the 11, and then the positive would be the 2. And then our final one, x and x. And again, we have a negative at the end, so our signs are different, and the bigger number will get that negative. So let's do our factors of 16. So we have 1 times 16, 2 times 8, and 4 times 4. And because this is a subtraction sign here, which of those pairs subtract to get 15? 16 and 1. The bigger number gets a negative, so minus is with the 16, and then the plus would be with the 1. And that's how you guys factor quadratic trinomials into two binomials. All right, so then our last example is solving a polynomial equation. So how do we use factoring to solve something? So do you see how there's an equal sign in the middle of the problem? So when you're going to use factoring to solve something, first of all, you need it to equal 0. Okay, so we need to have everything on the same side of the equation so it's in standard form. So the first thing we want to do is move this 21 over to the other side. And how would we do that? Well, we would have to subtract 21. So now we would have h squared minus 4h minus 21 equals 0. After you set it up so that's equal to 0 and you have a quadratic trinomial, now you're just going to factor it the way we've just been doing. So h squared would be split up into h and h, just like we did all the x's on the previous pages of the notes. Now we want to look for our factors of 21. So 1 times 21 or 3 times 7, and we want the pair that's going to subtract to give us this 4. So which pair, guys? That's right, 3 and 7. Now, this here, we know they're different signs, right? The bigger number in this problem is going to get the negative. So the 7 is bigger than 3, so the 7 gets the negative, the h gets the positive. So we've gotten it equal to 0, then we factored the trinomial that we had, but now because of the equal 0, we can actually solve. And we're going to do something called the zero product property. And what the zero product property is you take each of these factors and you kind of make them their own little mini equation. And the reason why you're doing that is because you have two factors here being multiplied together and they have to equal 0. Well, how do you get something to equal 0 when you're multiplying it? It has to be multiplied by 0, right? Any number times 0 is just 0. So we would want to say, okay, well, how could I make this factor here, this h minus 7 equal 0? Well, what number minus 7 equals 0? That's right, h would have to be 7. 7 minus 7 would be 0, and then if you multiply that times anything else, it would also be 0. So that's one of your possible solutions. Same thing on this other factor here. If I have h plus 3, how could I make that equal 0? Well, h could be negative 3, and that would make it equal 0. And then, of course, multiply it to anything else, the whole equation would equal 0. So that's how we find our two solutions using zero product property. So let's try this the next example. So if we want to solve this one, again, you see the equal sign, it needs to be equal to 0. So you would have to bring this 11x over to the other side. Now just make sure when you bring it to the other side, which we're going to do the inverse operation, which would be subtract, you have to put it in the right place. Remember, your standard form is ax squared plus bx plus c equals 0. So you need to have it in that order when you set it up. So when you move that 11x over to the other side, make sure you put it in the middle of the 30 and the x squared. Okay, so that's the first step, get it equal to 0. After you get it equal to 0, you want to factor your quadratic trinomial. So x and x. Now, what are the factors of 30? So I'm going to list them out here for you. I will put a factor sheet onto Google Classroom for you guys to print out if you want. Okay, so now which of these pairs of factors add up to this 11 that we have in the middle? Well, 5 and 6 are the only pair there that's going to add up to 11. And of course, the bigger of those two numbers, which is 6, is going to get the negative sign. And guess what? That was a plus here at the end. So the 5 is also going to get a negative sign. Remember, when that's a positive, they're going to be the same. So negative 6 and negative 5, when you add those, you get that negative 11 in the middle. But remember, when you multiply the two negatives, you get that positive. Now, because this one says to solve, after you factor, you're not done. You have to solve each factor. So basically, you're just setting them equal to 0 and solving them separately, which a lot of times you'll notice that it ends up just being the opposite sign, right? Because a number minus itself would be 0, or a number plus, a negative number plus would be 0. So in this case, we're just going to get x equals 6 and x equals 5, because each of those numbers would make the whole equation equal 0 if we plugged them both in. And I think that's it for today. So hopefully you guys, this helped you understand how to factor a quadratic trinomial into two binomials. And then at the end there, we use the zero product property to solve for those variables at the end. And we will practice this a little bit more on Tuesday as well. So please make sure you check in if you guys have any questions. Thanks.